Okay, so one more time. So we're going to construct the perpendicular bisector of a segment. So I'm going to just draw a random segment. Just doesn't matter how long it is. We can call it AB because it's a nice easy name. A, B. So what we're looking for is a segment that is perpendicular to AB and simultaneously bisects it. Okay, so now that we have our segment, we want to extend the radius of our compass here to be slightly more than the halfway point. See, this would be not long enough, right? So halfway point's like around this vicinity. I mean, anywhere larger is fine. I just think this is too big. You don't need it to be this big. So I'd say as long as it's maybe at the 3/4 marker or 2/3 marker, should be fine. And then the easiest way, especially since these aren't the highest of quality compasses, you can't really lock them, is they're pretty stiff though. I take the point, so we're going to draw 2 circles, one at each endpoint. You don't have to draw the full circle though. So I'm actually going to put the pencil point down and rotate the paper. So I do that, and then I'm going to come to the other side and do another one. If you want to draw a full semicircle, that's fine. The objective is draw 2 circle arcs that are long enough so that when I draw circle arcs from the other point, I'm going to get an intersection. So like, see how I messed up there? Not quite long enough, right? They're supposed to intersect. This one I did okay. Not a big deal. I'm just going to go back over to B. And I'm going to extend this one a little bit longer. So now we have the intersection of both of those circles, right? The radius is the same. So where they intersect, that's a good thing. All right. And then at those 2 points, point 1, point 2, we're going to take our straight edge that belongs to the flat part of this protractor, and then going to connect the dots. I think this looks better on this paper too. Okay, so is it a perpendicular bisector? Well, one thing we could do is measure the angle. Very perpendicular. Gonna mark that. Bam, bam. And then, is it a bisector? If it's a bisector, that means M would be a midpoint. So let's use this as a measuring tool. And you can see that it is, in fact, exactly in the middle. So that's how you construct a perpendicular bisector of a segment. Now, the other thing that you might want to just take note of, students, hey guys, could you just keep it down a little bit? Thanks. Unless you want to be in the YouTube video. All right, so now, there's one other thing that you need to note. So we just created a perpendicular bisector. Could somebody in the class tell me, if I were to plot a point here, I'm going to call it point C. What do I know about point C and how it relates to the endpoints of segment AB? Somebody tell me, how does point C relate to my endpoints? If you were to connect the dots right now, CA and CB, what has to be true? Pardon me? They're congruent? Why can I comfortably say, not only is this congruent, right, because it's a perpendicular bisector, these would have to be equal to each other. So we know that AC is congruent to CB, right? Why is that? That's called the perpendicular bisector theorem, right? Any point that's on a perpendicular bisector is equidistant to the endpoints. So I can take another point down here. It's on a perpendicular bisector. Call it D. That means that AD and BD those are also the same. So you'd say AD is congruent to DB. Why? Perpendicular bisector theorem. Are we sure that's true? Double check. Look, use your compass. Same radius. It's perfect. All right. So there you go.